Hello everyone. Today we're going to start with chapter 9, section 8. It is titled Dilution, and this is on page 273 of your book. So, many solutions from orange juice to chemical reagents are stored in high concentrations and then prepared for use by dilution. That is, by adding additional solvent to lower the concentration. So the first thing that we are going to define is dilution. And that is adding additional solvent to lower the concentration. For example, you might make up 1/2 gallon of orange juice by adding water to a canned concentrate. In the same way, you might buy a medicine or a chemical reagent in concentrated solution undiluted before use. So an example would be orange juice in a can. So the key fact to remember about dilution is that the amount of solute remains constant. So we're going to note that solute remains constant. That means it does not change. Only volume is changed by adding more solvent. If, for example, the initial and final concentrations are given in molarity, then we know that the number of moles of solute is the same both before and after the dilution, and can be determined by multiplying molarity times volume. So the first equation that we need to know here is the number of moles is equal to molarity, which is mole per liter, times volume, which is liter. So because the number of moles remains constant, we can set up the following equation where M1 and V1 refer to the solution before dilution, and M2 and V2 refer to the solution after dilution. So the next equation we need to know is moles of solute equal M1 V1 equals M2 V2. So this number here, this is going to be solution before dilution. And the second part of the equation is going to be solution after dilution. This equation can be rewritten to solve for M2, the concentration of the solution after dilution. So it can be written as this as well. This is just going to rearrange this equation. So if we solve for M2, M2 can be equal to M1 times V1 over V2, where this here is going to be the dilution factor. That's what this is called. The equation shows that the concentration after dilution can be found by multiplying the initial concentration by the dilution factor. So we're going to define dilution factor, which is the ratio of the initial and final solution volumes, which is V1 over V2. So if, for example, the solution volume increases by a factor of 5 from 10 milliliters to 15 milliliters, then the concentration must decrease. So if solution volume increases, that means that concentration must decrease. The relationship between concentration and volume can also be used to find what volume of the initial solution to start with to achieve a given dilution. So some other equations that we need to know. So since M1 V1 equals M2 V2, then V1 equals V2 times M2 over M1. In this case, V1 is going to be the initial volume. And that must be diluted to prepare a less concentrated solution with volume 2. The initial volume is found by multiplying the final volume by the ratio of final and initial concentrations. For example, to decrease concentration, so to decrease concentration, the initial volume must be decreased. Although the preceding equations and following examples deal with concentration units of molarity, it is worth noting that the dilution equation can be generalized to other concentration units present in this section. So this can be applied to other things. So this can be concentration 1 of volume 1 also equals a concentration 2 of volume 2. So that's the last equation that we're going to do before we do some examples. So the first example that we're going to do is going to be 912, which is going to be what is the final concentration if 75 milliliters of a 3.5 molar glucose solution is diluted to a volume of 450 milliliters. So the equation that we're going to want to use is M1 V1 equals M2 V2. But we want to solve for M2. So we want to solve for this. So to do that, we're going to divide each side by V2. So the equation that we are going to use is now M2 equals M1 V1 all over V2. So we know that M1 is 3.5 moles of glucose, and that V1 is also going to be 75 milliliters. And the final volume is going to be 450 milliliters. So milliliters cancels, so we're left moles. So when you do this math, your answer comes out to be 0.58 moles of glucose. So there is one more example that I would like to go over, and that is going to be 9.13, which is going to be dilution of solutions volume. So, aqueous and sodium OH that's sodium hydroxide, can be purchased at a concentration of 1 molar. How would you use this concentrated solution to prepare 750 milliliters of 0.32 molar NaOH? So the first equation that we're going to be using is the same, so it's going to be M1 V1 equals M2 V2. But here we want to solve for V1, so you have to divide each side by M1, so then these cancel. So you're left with V1 equals V2 M2 over M1. When we plug this in, we get V2 is 750 milliliters. M2 is going to be 0.32. And then M1 is going to be 1. So the answer that we get here is going to be 240 milliliters. So for homework, you will be completing 9.19, 9.20, and 9.21, which is going to be on page 275.